All right, homework B6, complex numbers, worksheet number 1. Let's get it. So number 1. Square root of negative 169. All right, I'm going to use the fact that I is equal to the square root of negative 1. Can you see that? Yeah, you can. All right, so anytime I have a negative inside the square root, I'm going to pull that out as I. Okay, and then handle the square root like normal business. So 169, that's a perfect square. This is going to be 13i. So answer number 1 is 13i. Number 2. Square root of negative 4/9. All right, I'm going to pull the negative out as I. At the same time, so the negative I, the negative comes out as I. Then square root property says I can take the square root of the top and the square root of the bottom separately. So square root of 4 is 2, square root of 9 is 3, and an I is just along for the ride. 2/3 I. It's the answer to number 2. All right, square root of negative 49. I'm going to pull the negative sign out as I. And then the square root of 49, that's a perfect square, so 7i. It's not bad. You got to be able to recognize the perfect squares. It definitely comes in handy for sure. Number 4, square root of negative 75. 75 is not a perfect square. Nevertheless, I'm going to pull the negative out as an I. Square root of 75. I'm going to factor this into its prime factors using prime numbers. So actually I'm going to do 3 times 25. 25 is 5 times 5. So here's a pair. That's going to come out. So I'm going to get 5 root 3 I. Nice imaginary number. Okay. Okay, this one's a little bit more interesting. 2i squared. So I have one term being squared. I can square each term. I can square the 2, square the I. So I'm going to get 4i squared. So we have a list, right? I to the first power is I to the second power, negative 1. I to the third power, negative I to the fourth power, 1. So we're always keeping this list in the back of our mind in case we ever run into any of them. And look right here, I squared is negative 1. So this piece here is negative 1. So it's essentially 4 times negative 1. So negative 4. That's our answer. That one's fun. Okay. Number 6. Okay, order of operations, handle the parentheses first, then exponent. So just like the previous problem, I'm going to square the -3 and square the I. So it's going to be 5I. -3 squared is 9I squared. I know that I squared is -1. So this is 9 times -1. So that's going to be -9 times 5I. This is going to be 9 times 5, -45I. Not bad. All right, number 7. Okay, this one's a little bit more spicier. We got 2 times being multiplied. First thing I'm gonna do is pull out the i's. Where everything here is being multiplied. So really, all the i's can move to the back. Or I can do the outside times the outside, inside times, or the square roots times the square roots, and the i's times the i's. Let's do that. So 2 times outside times outside, I have 2 times 1/8. Right, this is, all whole numbers are over 1. So this is gonna be top times top, bottom times bottom. I'm gonna get 2 8s, which is basically 1/4. Right, simplify the top, simplify the bottom. So that's 1/4. 50 times 2 is 100. Square root of 100, that's 10. I times I squared. That's basically -1. So what do I got? I have 1/4 times 10 times -1. 10 is really over 1. So I'm going to get -10/4. But this is going to cancel. -5/2. -5/2. Right? Because here, 2 goes into 10 5 times, 2 goes into 4 2 times. You can't forget about your negatives. I think they're going to be the most forgot about part. Like, they can get lost in translation. All right, number 8. -5, 20. All right, so I'm multiplying 2 square roots. One of them has a negative, so I know I is going to be at the back. 5 times 20. What is that? 2, 4, 6, 8, 10, 100. And the square root of 100 is just 10, 10i. Okay, let's see. For like number 9, there's a typo. There's supposed to be a multiplication sign, but there's a box for some reason. All right, square root of 2, negative 2, square root of -x, times 5, square root of -y. Okay, first thing I'm going to do, pull out the negatives as I times 5 Okay, outside times outside, -10. Square root times square root. So I'm multiplying square roots. I multiply the arguments, the part inside. So this is going to be the square root of xy. I squared, right? I times I. We know this is just -1. So -1 times -10 is +10 xy. That one was fun. I like that one. Okay, here we go. Number 10. I to the 17th power. So I to the 17th power. It really doesn't matter what power they give me, right? Because this pattern will never fail. It'll never break. So I know that every 4, it repeats. So 16, right? This is 17. Well, I know that 4, 8, 12, 16, 17. It's just I. It's recursive, right? It's recursive, so it'll keep repeating. So I to the 17th power is just I. It's easy. 11, 59th power. Okay. I to the 59th power. What number is this? 11. All right, so if we figure out what multiple of 4 this is, I'm dividing it by 4. 1, 9, 6, 16, 3. All right, so 4 goes into 59 16 times. So that means remainder 3. So it's going to be 4, 8, ... And then remainder 3, 1, 2, 3. So this is going to be -I. Right, whatever this power is, if you divide that by 4, right, if you divide this by 4, you're going to get one of these things to come out, right? Because if it's a remainder 1, it'd be this. If it's remainder 2, it'll be this one. Remainder 3 is going to be this one. And if it's a remainder of 4, well then that wouldn't make sense because 4 would go into 4 evenly, and then you would get a number up here. So I like this. If you just divide this by 4, whatever the remainder is, that's the 1. Right? You're always going to have a remainder of 1, 2, or 3. Or it's going to go into it evenly. So that's the cheat code. I-34. These are nice. So again, 4 goes into 34 how many times? Not 9, because it'd be 36. So it'd be 8. All right, 8 times 4 is 32. Remainder 2, I squared, -1. Okay. R squared is equal to -64. 624. Okay. Take the square root of both sides. R is equal to plus or minus, because I introduced the square root. I'm going to pull the negative out in this step. Now to prime factorize 624. Is it a perfect square? Maybe. I don't think it is, because 625 would be 25. So it's definitely not. So 3, 1, 2, right? 2 goes into that. Divide by 2 again. This is going to be 156. 2 again. 78. 2 goes into 15 7 times. 16, 8. 2 is going to go into this. I want to say 36. 2 goes into 7, 3, 18. Oh no, 39. 39. Right? Because 2 goes into 7, 3 times that's 6. 1 left over, bring down the 8, 2 and the 18 goes 9. 3 goes into this 13 times. So where are my pairs? Here's 1, here's 2. So R is equal to plus or minus 2 times 2 is 4, root 3I. No, 3 times 13 would be 39. So 39 inside the square root, and then I is outside. So R is equal to plus or minus 4 square root of 39 I. Yep. What number was this? It's 13. This was 13. All right, 14. S squared minus 22 equals negative 112. All right, I'm going to add 22 to both sides. All right, so this number is going to get smaller. So negative 90. S squared is equal to that. Take the square root because I want to undo the square. So S is equal to plus or minus square root of 90. I'm going to pull out the I. I pull it out every time. This is going to be 3 and 30. Prime factorizing 90, right? 3 and 30, 3 and 10. Okay, I have a pair. Actually, 10 is 2 and 5, but you can't pull anything out of here, right? So this is just 10. So S is equal to plus or minus 3, because the 3 can come out, square root of 10 I. Okay. $15. 9 minus 4y squared. Positive 57, okay? Okay. I'm gonna subtract 9 first. I'm trying to get y by itself. So this is negative 4y squared. 68? No, it's getting smaller. 48. So 48, right? 48 plus 9 is 57. Divide both sides by negative 4. Y squared is equal to negative 1. So 4 goes into 4 once, 4 goes into 4 once, 4 goes into 8 twice, so 12, negative 12. Taking the square root because I want to solve for y. Y is equal to the square root of 12i. Prime factorize 12, we get 3, 4 times 4. 2 times 2, 2 comes out. Y is equal, like I forgot the plus or minus. Plus or minus 2 square root of 3i. $16. Okay, 16. 3p squared plus 7 equals negative 9. P squared plus 4. All right, I'm going to move all of the variables to one side, all the numbers to the other side. So I'm going to add 9p squared to both sides. So 9, 10, 11, 12. So 12p squared. I'm going to subtract 7. So I'm going to get -3. Divide both sides by 12 because I'm solving for p, trying to isolate p. P squared is equal to, this cancels, -1/4. I can already see where this is going. So take the square root of both sides. P is equal to, plus or minus, I'm going to bring out the I, and this is where you take the square root of the top, square root of the bottom. So square root of 1 over the square root of 4. Or I can split that up. I kind of skipped over a step, but we should be pretty comfortable at this point. Square root of the top, square root of the bottom. So what's the square root of 1? 1. Square root of 4 is 2. So plus or minus 1/2i. Right, all these little properties, like the square root properties, you got to be able to be Johnny on the spot with those. Okay, number 17. Looks like the problems are changing. Problems are changing. 17. 6 minus 3i plus 5 plus 4i. Okay. Instructions say write the expression as a complex number in standard form. So a complex number in standard form. Standard form looks like that. A plus bi. Where this is the real part and this is the imaginary part. So we're just combining like terms essentially, right? The real part plus real part, imaginary part plus the imaginary part. So 6 plus 5 is 11. -3i plus 4i is just 1i. There it is, 11 plus I. This is the, you add together two complex numbers, you get a complex number. The real part's 11 and the imaginary part is I. All right, let's see. 18. -2 minus 6i. -4i minus 6i. Is that correct? Yeah, that is. Okay. Here, on the last one we were adding, here we're subtracting. So we're going to have to distribute. So -2 minus 6i minus 4i plus 6i. I knew that looked funny. Okay, so real part plus real part, -2 minus -4, -6. -6i plus 6i, those cancel. Like I have -6 and then I add -6, that gives me back to 0. So, right, this is just plus 0i. But we don't worry about the 0i. The answer is just -6. $19. $8 plus 20i. Plus 20i minus negative 8 plus 12i. I'm going to distribute the negative sign. So it's going to be 8 plus 20i plus 8 minus 12i. Combining like terms, this is going to be 8 plus 8 is 16, 20 minus 12, negative 8i. So 16 minus 8i. That's the answer. All right, 20. 10 minus 2i. Plus negative 11, 7i. Okay, since we have a binomial being added, two binomials, right, being added, or binomials, two complex numbers being added, we can just drop the parentheses and add combine like terms. So 10 plus 11, negative 1. Negative 2 plus negative 7i is negative 9i. So negative 1 minus 9i. All right, 21, negative 1 and 4, plus negative 9, negative 2. Okay, again, adding, I'm just combining like terms. So this is going to be negative 10, right? Negative 1 minus 9 is negative 10. 4 minus 2, 2i. 22. Eight minus 5i. Negative 11 plus 4. Okay, 8. So here, this is negative, right? We just can't combine like terms. We have to distribute first. So this is going to be plus 11 minus 4i, and then this part's unaffected, right? It just comes down. 8 minus 5i. So combining like terms, we get 8 plus 11, 19. Negative 5 minus 4, negative 9i. 19 minus 9i. Now it's 23. That was 22. Here's 23. Three plus 2i. Plus 5 minus I. Plus 6i. Okay, so we're in three complex numbers. Again, they're all being added, so we're just combining like terms. The real parts, 3 and 5 make 8. 2, negative 1 plus 6. So 6 and 2 make 8. 8 minus 1 is 7. So 7i. Last one, 24. Negative 8 minus 3 plus 2i plus 5. Oh, that's the last problem. Hold on. Minus 9 minus 4. Okay, you can't just add like terms, right? This negative has to distribute, that negative has to distribute, or really these minus signs have to distribute, right? It's an operation. So negative 8 minus 3 minus 2i, distribute again, minus 9 plus 4i. Now we can combine like terms. 8 minus 3 minus 9. So 8, 9, 10, 11, negative 11, minus 9, negative 20. Negative 2i plus 4 plus 2i. They almost got us on that one. So negative 20 plus 2i. That was number 24. That was the last of it. All right, good luck.